Hello, lovely people. This is your instructional video for Wednesday, April 21st. We're going to be talking about the areas between curves, and actually I should have written on this main screen the area between a curve and the y-axis, so between horizontal lines. First, let's talk about the area between curves conceptually. Let's say we've got maybe two different trig functions. All right, so let's just kind of graph them here. And we are trying to find the area between these two curves at some defined section and some defined interval. So let's say we're trying to find this area. Let me mark that A. Well, what we could do is imagine that that is quite simply the area under the first curve. Let's call this the top curve. I'll mark this in blue. That's going to be the integral of this, assuming that these are both positive functions, minus the area under the second curve. So that'll be this purple one, minus this area. So essentially, what happens when we subtract that bottom area from the larger big area, just like in a geometry problem, we're going to get the area in between the two curves. So I'm going to show you how to work this out just using your graphing calculator. Let's take a look at this example problem. Sketch the region bounded by these two graphs, all right, and the line x equals 3. Find the area of the region. All right, so let's take a look. Here we go. Oops. Now I've graphed these two in my graphing calculator. Ignore that for now, please. And I can see that the graph generally looks like this. All right, so I'm just going to copy a little sketch of this graph. I've got a rational function and a square root function, yeah? We have, whoopsies, something that looks generally like this. So our square root function shifted left. This is also something like this. Like that. All right, and so the area we're trying to find is between these curves and x equals 3. So let's visualize that. Let's just say this is x equals 3. Essentially, what we want to find is this area. Boop, 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 boop. So our first question is, well, what is this point? So we can kind of easily find that point simply by solving, setting those two functions equal to each other and solving. I'm just going to use my graphing calculator to solve. So I have what? X plus 2 equals 1 over 2x plus 4, square both sides. X plus 2 equals 1 over 2x plus 4 squared. All right, and then I'm going to have x plus 2 times 2x plus 4 squared minus 1 equals 0. Let me just use my graphing calculator to find the 0 of this function, or zeros of this function. Pause right here, you do the same. Okay, I got x equals approximately negative 1.37. All right, so let me jot that down. Now, what do we want to do? Well, we need to use this value as our lower bound for the integral that we're going to calculate just using our graphing calculator. So what we can tell our calculator that'll make this problem a whole lot easier is to take the integral of the subtraction of these two functions. So if this is y1 and this is y2, what I'm going to say is, hey, graphing calculator, take the integral of y1 minus y2 and take the absolute value just in case we get a negative sign. I could even do y2 minus y1, but what if I subtract them out of order? Let me just call it the absolute value. And we're going to say this is between 1.37 and positive 3. Now let me show you how to put y's into your graphing calculator, in case you don't know how to do that. Here's how we do it. Let me just clear this out. First of all, you have to have your original functions in there in order for it to subtract them. So you should have the square root of x plus 2 and 1 over 2x plus 4 in some y's. Now here, I'm going to take the absolute value. So math, right arrow over abs, all right? And here I want to say y1 minus y2. Vars, this indicates variables. Y variables, it's right arrow over. Function, yes, we're talking about a function. And it's asking which y variable. I'm going to just take y1 and say minus and do that again, finding y2 as my second one. All right, so I am subtracting y1 and y2. Why? Because that's where I put those functions originally. And I turned the first two functions off on the graphing calculator so that when I calculate my integral on the calculator, it doesn't mess with y1 and y2. So I'm just going to go straight to second calc. Number 7 here is our integral. We need to give it a lower limit of, what did we say, negative 1.37. Our upper limit is 3. And just take a look at where that shading is and see if it kind of matches up. Yeah, it totally matches up. So our value of our integral, meaning the area of this shaded area, the area of the shaded area, whatever, is 6.08, I believe that says. So that's our answer. Approximately 6.08 units. And remember, that should be a positive value. Let's do one more. Find the area of the region bounded by y equals sine x, y equals cosine x equals 0, and x equals 2 pi. I'm going to pause and put these two y equals into my y1 and y2 on my calculator. You do the same. Okay, so I put the sine x and the cosine x in there. I've turned off this absolute value of y1 minus y2. It's because I don't want it to graph it. I don't want to graph it, but I am going to use that later when I'm finding the shaded area. So let's just visualize this first. Remember, when you have trig functions, you want to go to zoom 7 because that is going to give us our axes marked in radians. Oops, what did I do? That is not correct. There we go. So sine, cosine, we know what it looks like. Now this one's a little bit easier because we don't have to find a point of intersection. It's giving us our left, our lower bound and our upper bound. So x equals 0 and 2 pi. So we can see the area that we're looking for is going to be this little smidge, it's going to be this smidge, and it's going to be this smidge, and that smidge. All right, those are technical terms. So now let's just use our graphing calculator. Let's go back to our y equals. I'm going to turn on absolute value of y1 minus y2, enter on that equal sign, turn off the other two because I don't want those graphs to mess with my calculation of the derivative. Second calc, option 7, boing, 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 right? Only positive values. We said from 0 to 2 pi. 2 pi. Okay, it's taking a long time. Ooh. All right, we get approximately 5.66. All right, so that is from 0 to 2 pi. All right, so let me just write that down. We kind of just did this all on our calculator. Approximately 5.66 units, whatever they are. Okay, now let's talk about in our last 5 minutes. First of all, this is a generalization. You'll find it in your, you'll find it in your reference material. Let's talk about the area between a curve and the y-axis. So previously we were talking about finding the area between the x-axis and a curve, right? The region bounded between the x-axis and a curve. But what if we wanted to find the area bounded between the y-axis and a curve? So let's say, for example, some horizontal line here. We wanted to find this area. Okay. Well, now we're going to have to start taking the derivative of y. And what we're going to have to do is get y as our subject, meaning x as a function of y. So let's do this. Find the area of the region bounded by the curve y equals x squared and the y-axis where x is in the set of numbers from -2 to 0. Okay, first of all, let me just sketch this graph. Y equals x squared, doobie-doobie-doo. Boop. That is not the most beautiful parabola, but you know. From -2 to 0. Okay, so from -2 to 0. First of all, let's find out what our y value is here. You know that if y equals x squared, this is going to be 4. And so I want you to keep that in mind. This right here is 4. Boop, 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 boop. 4. All right, let's get when x equals 0. Oops, x squared, y equals 0 squared. We know that y is going to equal 0. So this is our other boundary line. Let me do that in a different color. These two boundary lines. Doot, 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 doot. Only we are just looking at the area bounded by the curve, the y-axis, and over this interval, this is the area we're trying to find. 1 second, sorry. This part is what we're looking to find the area of. Now we could use our calculator, but let's do this strategically. So first of all, what we are talking about is this function, y equals x squared. But since we're dealing with horizontal lines, which have equations y equals something, we need to get we need to get x in terms of y. So let's take the square root of both sides. And here we know that x equals, yes, the positive and negative square root of y. But since we're only dealing on the left side of the graph, to the left of the origin, we're actually dealing with the negative square root of y. So this is our function. So we're going to take the integral from our lower bound of 0 to our upper bound of 4 of this function, square root of y. So I'm going to call this negative y to the 1/2. Sorry, that's a negative. And since we're talking about area, I'm just going to call this an absolute value. And so let's use the power rule there. I'm going to pause this video because I'm running out of time. Use the power rule there, find the derivative. Ooh, I'm sorry, this should not say dx, it should say dy. The derivative of negative y to the 1/2. All right, and so when I use the reverse power rule, I should get negative 2/3 y to the 3/2. I'm going to use that integral notation. So let me evaluate this right here at y equals 4 and at y equals 0, subtract them, and take the absolute value of that. Do that on your own, and I'll do that here. All right, and you can see we're at the end, we're going to get positive 16/3 because when we evaluate for y equals 4, we're going to get 16/3, and when you evaluate for y equals 0, you're going to get 0. Subtract them. Sorry, you're going to get negative 16/3. Subtract them. You're going to get negative 16/3. Take the absolute value of that, and you have positive 16/3. Let me go over one last example like this. This is exercise 11H. I'm just rewriting the problem. I want us to get x in terms of y. And now let's take the integral of this. Remember that this is going to be the integral of 1 over y, which is natural log. Remember, your lower bound is 1, upper bound is 3. All right, and here if we just do this in our calculator, we're going to get 3.30. Just take that final step. Remember, sorry, this should have actually been the absolute value. I didn't get a negative number, so it didn't matter. All right, examine that integral and write to me if you have questions.